Welcome to Activity 5.4, Energy Transfers and Systems. So open up your books to Activity 5.4. This year it's page 48, but please realize that the page numbers do change from year to year depending on the publication of the book, and sometimes the publishers change the book up a little bit. So go to Activity 5.4. It's called Energy Transfer and Systems. So the learning target for today is we're going to investigate energy systems. After today, you're going to have a much better idea of what an energy transfer or what a system is and how energy can be transferred from one system to another. So the expectation for you is that you're going to be able to draw an energy transfer diagram for the basketball and a tennis ball bouncing together. Now, one thing I'll let you know is when you look at your book, a lot of times it'll say racquetball, racquetball, racquetball. But we've switched out the racquetball with a tennis ball. So wherever you see racquetball, don't get confused. Just use a tennis ball instead. So we're going to explain what a system is, and we will use an energy transfer diagram to describe what happens to the energy when a tennis ball and a basketball are bounced together. So the procedure, the very first thing I want you to do on the first page, it says in Activity 5.2, you recorded observations of the basketball and tennis ball bouncing. What I want you to do is draw an energy transfer diagram for the basketball and the tennis ball. So we've drawn a couple energy transfer diagrams. We've already drawn, we drew one in the last Activity 5.3, and we also drew an energy conversion diagram, or energy transfer diagram, in Activity 5.2. So go back in your book a couple times and see if you can draw this energy transfer diagram. So go ahead, pause the video, draw an energy transfer diagram for the basketball and the tennis ball, and then hit play again when you're done. All right, so you've had a chance to do it. You're not going to see the answer now. You'll see the answer when we go through this activity. So make sure you've got this done. So next, if you think of the basketball and a tennis ball separately, the amount of energy seems to change, increasing for one, decreasing for the other. If you think of both the basketball and the tennis ball together, the amount of energy seems to be the same. It is simply transferred from one ball to another. So does this make sense? When you bounce the two balls together, the basketball bounced less when it had the tennis ball on top, and the tennis ball shot way up. So somewhere the basketball lost energy or seemed to lose energy, and the tennis ball seemed to gain energy. But if you put them together in the same system, if you referred to them together, well, energy was simply transferred from one object, the basketball, to the tennis ball. So when we think of things together in this way, it's called a system. If you think about the basketball and a tennis ball together as a system, then the energy in that system is conserved. Again, in science, we cannot create nor destroy energy. It's got to be somewhere. So it was transferred from the basketball to the tennis ball. So let's take a look at this making sense question. It says, you observe that the basketball and a tennis ball eventually stop bouncing. What other objects in a system, or what other objects are in the system with the basketball and the tennis ball? So let's stop and think about it for a second. All right, the basketball stops bouncing. Well, the tennis ball eventually stops as well. So we know that some of the energy was transferred from the basketball to the tennis ball, but when they both stop bouncing, where did the rest of that energy go? It had to have gone somewhere. So go ahead, pause the video, and just give me a couple ideas. Where do you think where do you think the energy went? What other objects are in the system? All right, so make sure you have an answer. We're going to go over the answers, my idea of what a correct answer is at a future time. So don't forget to do this. Otherwise, you may get this marked as being not done. So let's look at number 2 here. It says a system can be made of one or more objects. Thinking of the possible systems that can be made of objects involved in the basketball and tennis ball demonstration. In which system does the energy decrease? So let's think about it for a second and answer this. So in which system does the energy decrease? Go ahead and put what you think is an answer. Just a sentence. In which system does the energy decrease? Okay, go ahead and unpause it. So thinking of the same thing. Thinking of the possible systems that can be made of objects involved in a basketball and tennis ball demonstration, in which system does the energy increase? So go ahead, pause the video and think about an answer here. Just a sentence. In which system does the energy increase? All right, go ahead and hit play again. So, thinking of the possible systems that can be made of objects involved in a basketball and tennis ball demonstration, in which system does the energy stay the same? And now again, if you're getting confused about this, let's think about it. So the basketball could be considered a system. The tennis ball could be considered a system. The tennis ball and the basketball together could be considered a system. And think about other parts. Could the floor be considered part of the system? Could the air be considered part of the system? So in which system does the energy decrease, the energy increase, and the energy stay the same? So make sure you have questions for this. Otherwise, it'll appear as if you're not done. So you want to make sure you have it done for when we discuss this. So some of the key takeaways today. If you think of the basketball and tennis ball separately, the amount of energy seems to change, increasing for one and decreasing for the other. However, if you think of both balls together, the amount of energy seems to be the same. It is simply transferred from one ball to the other. When you think of things together in this way, it's called a system. Now, if you think of both the basketball and the tennis ball together as a system, then the energy in that system is conserved when one ball hits the other. Now, this isn't entirely true because eventually both the basketball and the tennis ball seem to stop. So what are the other parts of that system? If you said the floor, you're correct. If you said the air, you're correct. Now, you've also learned that some things seem to lose energy while other things seem to gain energy. Anytime an object or a system seems to get more energy, the energy of another object or system must decrease by the same amount of energy because it's going to be transferred. You cannot just get energy from nowhere. The energy has to come from somewhere. Likewise, you can't just lose energy and it goes nowhere. It's got to go somewhere. So when one part of a system loses, another part must gain. So what could be the reason? What could be the reason one thing slows down or stops faster than the other? So what do you think about that? You got to think about things like friction between, say, the pendulum and the air, or when the basketball was bouncing, did it make a noise? Well, that's sound energy. That requires energy. So some of the energy was transferred to sound energy. So it didn't just go anywhere, it did get transferred. So next thing we're going to do is we're going to add some scientific principles. The first one is energy can be transferred between systems. So go ahead, pause the video now if you need to, and play it again when you're done. 9 says energy cannot be created nor destroyed. So just put that down. You don't need to put this the whole parentheses down. I just wanted to explain it a little bit more. It says if energy appears to be missing, either it has been transformed to another type or it has been transferred to another system. So just understand that energy cannot be created nor can it be destroyed. So go ahead and pause the video if you need to. Write this down. And hit play again when you're done. So let's go through the answers now. So for this one, it said in activity 5.2, you recorded observations of the basketball and tennis ball bouncing. It says draw an energy transfer diagram for the basketball and the tennis ball. So here we have the basketball. It transferred KE, so we have an arrow to the tennis ball, which got its KE from the basketball. So how did you do? Did your energy transfer diagram look very similar to this? Now, if you put KE to KE, that is absolutely fine. So the next one I want to go over, you observe that the basketball and the tennis ball eventually stop bouncing. What other objects are in the system with the basketball and tennis ball? If you said the ground or the floor, that's great. You're absolutely right. So the ground that the basketball and tennis ball bounce off and the air particles, or if you said the air in the room, the air particles, that's absolutely correct. So if you had those two things, great job. Now, this next question, this is the tough one. This is the question that really cements in. If you could answer this, you got it. You did a great job. So in which system does the energy seem to decrease? If you said it seemed to decrease in the basketball, when the basketball was all by itself, you're correct. So the basketball could be by itself a system. The tennis ball could be its own separate system. Together, they're a system. So in which system does the energy decrease? Well, the basketball. How do we know? It didn't bounce as much the second time, or when you had the basketball on top of it. Or not the basketball, but the tennis ball on top of the basketball. So in which system does the energy increase? Well, it seems to increase with the tennis ball. Yeah. So the tennis ball by itself is a system where the energy increases at the start because it initially bounces higher, but then after time it stops bouncing altogether. Now the air is a system where the energy increases because the basketball and tennis ball transfer their energies to it. So if you said the tennis ball, that's great. If you said the tennis ball and the air particle, absolutely. That's the slam dunk of an answer if you got both of those. Now, how about where the energy stays the same? Well, if you put all of it together, the basketball, the tennis ball, the air in the system, the floor, because you get that sound energy. If you had all of those, you're absolutely correct. Because according to scientific principles, energy cannot be created nor destroyed. So make sure you have this lab done. Make sure you have correct answers. So if your answers weren't correct, erase them, put in the correct answers. Because remember, you can use this book on the test. As always, if you have any questions, make sure you ask me in class. Thanks.